Hey, hey! Welcome to this investigation briefing. I've gathered you all here to help me solve a serious case. Here's what we know. At exactly 7:12 yesterday, our CI reported major slowdowns in production. New relic showed increased load times in the tens of seconds, tens. That means enough time to go to Ynet, check Instagram, check Facebook, and then go back to Ynet. Not only that, Sentry started lighting up like a Christmas tree. To top it off, a user contacted us, our support department, and you know it's always a bad thing when a user talks to us. One thing we know for certain, our app's performance is dead. We sent two junior investigators, two junior front-end investigators, but we haven't heard back from them yet. As of now, we have no leads, no time, and no patience left. Now, before we dive in the case, let me introduce myself. My name is Opher. I'm a developer, a designer, a musician, and sometimes a fake police commissioner. In my day-to-day, I'm a principal engineer at HUD, and we have a really cool and unique system that allows you to figure out what the hell is going on in production. If you have Node or Python backends, talk to me. Now, for anyone who's new to React or doesn't really know its dark corners, let me give you some insights into what we're dealing with. React usually is described as aiming to solve three problems: efficient DOM manipulation, UI state management, and reusability of code and components. Now, we're going to focus primarily on the DOM manipulation. DOM as in data object model, which is how a browser figures out what exactly needs to be done in the page and how to present this to the user. Now, the way it does this is by employing something called a virtual DOM. You see, really quickly, it's really expensive to do manipulations in the DOM, in the browser. So the way React figure out how to solve this issue is that they themselves keep their own data model and update it in memory, and then after batching and during their own black box magic, they update it and then minimize the updates to the actual DOM. Now, we have to ask ourselves, when does stuff get re-rendered? And to answer that, we need to figure out what exactly do I mean by render? Because render could mean many things. It could mean actually drawing pixels to the screen, moving textures to the GPU, figuring out layouting in the browser and layers and all that stuff. But in the context of this talk, when I say render, I mean specifically calling the component function, the functional component's render function, which is the JavaScript bit that defines the component. Now, one of the big questions is, what causes a React component to re-render? And then a short list would be, first, when a parent re-render, there is an asterisk there because we'll get to that in a second. When props change, when its state changes, or when its context changes. Now, this is not an exhaustive list by far, but things aren't so simple in the real world. That's why, against my better judgment, I've been forced to call in external assistants. To help investigate what exactly happened to our app's performance, I've called in several detectives to help us figure out what was going on. And our first detective is Batman?
I'm Batman.
Yes, I know. I'm the one who called you here. I didn't think we'd need Batman to solve performance issues, but I guess here we are.
I'm Batman.
Yes. We figured that out. What do you have for me?
Two problems. Two problems. First, the app had use context, which kept updating all over the place. The more it changed, the more chaos it created.
Interesting.
Second, it was creating new objects, arrays, functions, in props on every render. That constant churn adds up, Commissioner. It's unnecessary work. And in a case like this, unnecessary means slow.
Okay, those are solid leads. Let's break this down. Use context. What exactly is use context? So in the case of something that happens quite often in React, you have this pattern that's called prop drilling, where let's say you have a parent that needs to send the prop down the React rendering tree. Then you have the parent sending hello from app. This goes into the parent component. This goes into the child component. And then that goes into the grandchild component. And then if you have a really complicated tree, this gets passed further down the line, and you have to kind of update props on each component along the way. Context comes to solve this by allowing you to create something that's kind of like more global in nature. So you have like a context provider, which is where you define the value that you want to pass along the tree without passing it through all the components in the tree. And basically the way it works is that the message provider, in this case, is what gets the value, hello from app. Then that doesn't have to get passed along to the parent or the child, but the grandchild can use context to figure out how to get that without altering all the tree. The thing is, use context is a hidden foot gun. If you haven't heard the term foot gun, it means something that is very easily allows you to shoot yourself in the foot. And React has quite a few of those if you don't pay attention. This is what I mean. Let's take this authorization provider component. Basically, it gets some data from a payload and then provides to the context consumers the user email and the username, for example. But here's the thing. As you can see, the value is actually an object that gets recreated every time this context provider is called. So essentially, you're creating a new object which holds a new reference, and that reference changes. So every time the context gets rendered, all of the children, not all of the context consumers will get rendered, regardless of if username and user email change. Here's another example. Let's say you have a function, this function authorize, which gets passed down to context. Again, because this function gets recreated or redeclared every time the context is being rendered, the context function is being rendered, what ends up happening is that you pass that value, that reference that changes to the context consumers, and again, you get tons of re-renders, even though the function itself hasn't changed. So how do you actually solve that? You memorize those values. In the case of the object, you can always just memorize the object itself, and that way its reference doesn't change. And in the case of the function, you can do the same with use callback. And then pass that reference along to the context consumers. Anything else, Batman?
Optimize your renders, Commissioner. Gotham may be a mess, but your component tree doesn't have to be.
Thanks, though. Aren't you more about fighting crime than solving JavaScript issues?
Crime takes many forms. In JavaScript, that's the worst kind of crime.
But you're not really a detective, are you? You're more like a person dressed like as a bat going to beat people.
You're not really a police commissioner either, are you? You're just a nerd, standing in a room full of other nerds.
Fair enough. OK, thank you, Batman. Our next up is, oh no.
Go, Gadget, Desperate Cam. Hang on. Let me just. Go, Gadget, Bluetooth headset.
The Bluetooth device is connected successfully.
Gadget, are you driving on this call?
Of course, Commissioner. Multitasking is the future of crime solving. Besides, Penny upgraded the Gadget Mobile. fully autonomous, completely safe. Anyhow, go gadget performance insights.
Okay, what do you have for us?
Do you know what happens when you pile too many use effects on top of each other, Commissioner? You get a mess. A big, tangled, buggy mess. I tried to debug it myself, but even my Go Gadget debugger crashed halfway through.
That does sound inefficient.
Inefficient? Commissioner, it's a disaster. Instead of solving problems, it's creating extra renders, unnecessary dependency checks. It's an absolute chaos. Whoever wrote this was just tossing in use effects like sprinkles on a cupcake, without even checking if it was needed.
Okay, I see the problem. Anything else?
Oh yes, use memo and use callback. These are precision instruments, but they're being used everywhere. It's like the developer thought, why not memorize everything? So now, the app is spending more time memorizing than actually doing anything. It's ridiculous.
So you're saying they turned hooks into liabilities?
Exactly. Too much of a good thing, Commissioner. If they just stopped to think before deploying every hook they could grab, we wouldn't even be having this conversation.
Okay, thanks, Gadget. Let's break this down. Use effect. Quick recap. I'm not going to go through everything that use effect does, because that will take another complete talk. But just super quick recap. Use effect is used for. If you said side effects, you're wrong. It's used for data synchronization. Sorry. It can be used for side effects, but as a last resort. And if you don't believe me, just read the React documentations, which says only use effect as a last resort. Can't go into depth into that, but if you want to know more, there's an amazing talk by David Korshut called Goodbye Use Effect, and I highly recommend you do that. You go and watch that. So one of the biggest foot gun with use effect is derived values. And what do I mean by that? So let's say that you have this name component, which takes first name and last name as props, and then you want to output like the full name. So obviously, like you take first name and last name and do that as a use effect, and then set the state of the full name. But here's the thing: you can just as well do this, because that's not an actual side effect. The full name is a derived value of first name and last name. You don't need to use use effect, because what would happen is that you'd have an extra re-render every time one of those props change. So in this case, it'd be 1. But if you have a value, a derived value, and another use effect that relies on that derived value, and another use effect that relies on that derived value, you have tons and tons of re-renders for nothing. The other foot gun with use effect is missing cleanups. So take a look at this component, like window size, which registers a new event listener on the window, and whenever the window changes, it sets a new state and gets that value, and then you have that state. The thing is, this use effect gets called every time the component mounts. So the components might get mounted, unmounted, and then you have multiple add event listeners that never gets removed. So one thing to remember is every time you do use effect, you need to figure out whether you need to clean the effect that you're adding, so that when it happens, and if you use strict mode, it will actually mount twice and unmount twice, then you need to make sure that you clean up, otherwise you'll have a memory leak. Okay, I don't think that's all the performance issues. So we do have more guests coming in. Oh, finally, an actual detective. Next up is Benoit Blanc. Detective, what do you have for us?
Ah, Commissioner, a most fascinating case you've presented here. A tangled web of decisions, if you will. Now, I've spent some time unraveling this mess, and have come to an intriguing conclusion.
Okay, what do you have for us?
The app is guilty of two opposing sins. On one hand, it is downright negligent in its use of memorization, failing to use memo and use callback where they would have clearly reduced unnecessary renders. But on the other hand, where memorization is used, it's done so excessively and frivolously. Overuse of React memo on components that barely change.
So you're saying you're both overusing and underusing memoization?
Exactly. It's as if the developer couldn't decide whether to trust memoization or fear it. Instead, they've employed it haphazardly, sometimes ignoring it altogether, other times slathering it all over like butter on a biscuit.
So what's the impact of this behavior?
Chaos, Commissioner. Sheer chaos. Performance suffers where memoization was neglected, and the upwaste cycles where it's been over-applied. It's a textbook case of too much and too little, all at once.
Okay, Blank, thanks for the insights. Let's talk a bit about memoization. So if you recall, a component renders when one of its parents parent re-renders or when one of its props change. Here's the asterisks. Sometimes you don't want a component to re-render if one of the props change. And that's why we have a tool called React Memo. So in this case, we have a component called expensive component, and we memoize it by calling React Memo. This returns a new component which doesn't change if one of its props changes. However, here's the foot gun. Memoization is really simple to break down. So that means you do have the overhead of calling memoization, but you don't get the benefit of memoization. And this is some examples of how easy it is to break. Let's say your memoized components accepts children, like a children property or a sub-element. This automatically breaks memoization because every time you enter, you put in a new child, this is a new child that gets defined via reference, and then the component will get re-rendered. A way to solve this is to memoize the children themselves, but this gets a little cumbersome. So take that with a grain of salt. Another issue is that sometimes another developer will be working on your component and they don't know that your component is memoized. So what ends up happening is that they add more props to your component. And in this case, let's say they added style. And again, we're back to defining new objects on the fly. So the style object here is, again, recreated on every render as a new for reference. And again, memoization breaks. Next up is, OK, a professional from the FBI. Agent Mulder, what do you think about this case?
Something doesn't add up here. These aren't normal performance issues.
OK, what do you think is causing them?
Have you considered external interference, forces beyond our understanding?
You mean like what?
There are beings who have been known to interfere with JavaScript runtime environments. They're trying to disrupt humanity's progress in web development to keep us from advancing too quickly.
Right. And these beings, how are they messing with React?
They're introducing unnecessary re-renders through an advanced psychic feedback loop. Think about it. Have you ever actually seen a virtual DOM? Or are we just taking React's word for it?
Are you saying the virtual DOM doesn't exist?
I'm saying we can't rule out the possibility that the app's performance issues are the result of external tampering by someone or something that didn't want this app to succeed.
All right, Detective Mulder, I think we've got enough.
You need to look beyond the DevTools profiler. There's a bigger picture here.
Yeah, I'll keep that in mind. Moving on. Well, the beauty of software is that you don't have to do the guesswork of why things go wrong. You can just find out for yourself. And it's true that there are ghost in the machine bugs that are hard to figure out, but that's why we have visibility tools that allow us to exactly debug what is the cause of these things. And here's the list that I use, my favorite tools for figuring out React performance issues. The first is one that everyone uses, strategic console logs. And I'll give an example of how to do that in a second. Another one is deleting code. I don't mean like deleting your entire app, which obviously would solve all performance issues. But sometimes when you enter, you see a new problem and you don't even know where to begin. I just go into like main.app and start deleting stuff until you kind of figure out where you're standing and where the big issues are. It is surprisingly helpful. Next, there's a library called Why Did You Render, which spews out a lot of information into the console log about like what exactly causes specific components to re-render. There's a new tool called React Scan, which is kind of like a visual tool that shows you on the page what exactly happens. I'll show you that in a second. And then, of course, there's the dev tools. There's also, like, I'm not talking about new technology like a React compiler and other stuff that's in beta, because like most of us are working on older code bases that are never going to upgrade React at any point. So these are the tools that I'm going to stick with. Strategic console logs, my favorite is this, where some of the times you just want to figure out what prop changes causes which re-render, and then you don't have to reach out to any library or anything. You just plop down a new use effect. I know it's a use effect, and I said not to use it if you don't have to, but in this case, it's really helpful, and you don't push this to production anyhow. But you just use the prop that you want to test, and it's just console logs every time it renders. And if it happens like a million times, then you know that something is bad happened. This is why did you render. Basically, you give it a set of parameters, and then it says like, this component got re-rendered because this prop changed, or because of context change, or because of other stuff. It's helpful, but it's also really noisy. So like if you have...
Browser extension?
What?
Is it browser extension?
It's not a the question was it a browser extension? It's not a browser extension. It's a library that you npm install into your project, put it in the imports, and then hopefully remember to turn it off before you push to production. Next one is React Scan. It's kind of a new thing. It's also something that you can put in your import, and there's also like a separate server that you can run on any browser, even if on any site, even if it doesn't have that. And it allows you to visually see how when stuff gets re-rendered. I don't have time to go into in depth about dev tools, but these are like performance-centric tools. While React Dev Tool is kind of like more like a general thing. So in short, be careful with use context. This is like in every new code base that I've entered, one of like the major things that you find out is that use contexts are just all over the place, causing extra re-renders. Use effect, only if necessary. This is one of like the better strengths of React, also one of its downsides is kind of like misunderstood ways in which it works. Remember to memoize your expensive components, but not too much. Don't put memoize on anything that will just create the exact opposite effect. And you have visibility tools to figure out when things go wrong. That's what I have for you today. Our case may be closed, but React issues always prop up. So we need to be and stay vigilant. You can find me on Twitter or X or whatever, or on Blue Sky. And if you have more questions, I think we have a couple of minutes. And if not, come to me later. Thanks.